Welcome back to this final part of chapter 2. So basically I'm going to be showing you how to construct a stem and leaf display. We've seen how to do frequency distributions using bar charts and pie charts, how to visualize frequency distributions using Excel. But the stem and leaf displays, you can achieve the same thing using by hand. So essentially, let me just zoom in a bit. You could have data like this, for instance, and you want to construct a stem and leaf display. So to do this by hand, you basically, all you have to do is so if you want to do this by hand, you're going to have let me just get a table. Well, you wouldn't need a table if you're doing it by hand, but I'm just getting a table so I can so that my data can be, so that my work is neat. So anyway, so what you have to do here is to basically look for the for the smallest value. So this is your data. You want to start off with the smallest value. Smallest value is around 90 something, as far as I can see. You have 114, 99, 131, blah 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 blah. So this is your data, right? So you have 99. So you have the 9. You have the 90s, yeah. So let me just format. So remember, I'm just doing this. You basically do this by hand. I'm just doing this so that my work is neat, and of course I'm using my laptop. But you basically just write these values on a piece of paper. Let me just get rid of the grid. So I just want to get rid of the grid. So you have that, so that's okay. So you have the 90. So our data starts with 98, I think. So that's 98. Then you have 99. So those are the 90s, right? Those are the 90s. So the next value that you have, the next big value you have is the 100s. So you have 100. You have 100. I think, let me just get rid of the 90s now that I've used them. We had the 98 here. So now we do the 100s now. You have the 102. So let me get rid of this. You have a 104 in there. So you have a 104. You have a 100. Do you have any other 100? You have a 106 here. I think I have to add a new. So you have a 106, right? Let me get rid of this. Do we have another 100? We had a 104 in there. Is this another one? So we had a 102. We had a 104. Yeah. So we have a 104. We have a 100. Do we have two 102s? I think you can see why I'm deleting this. So that I don't get confused. So those are the 90s, right? So we have a 100, then we have a 102. So let's get rid of the 102. We have a 104. 104. Let's get rid of the 104 so we don't reuse it. We have a 106 here. need another column, it seems. Yeah. So we have a 106. Let's get rid of it. So we still have a 106 here. Yeah. So we have a 106. So those are the 100s. So we have to go to the 110s. So we have a 114 here. Yeah. So we have a 114. So let's get rid of that. We have a 115. 115 here. So let's get rid of that. We have a 117. Let's get rid of it. So we have a couple of okay, we have a 119. Then so this is actually an example from the exercise. Yeah. So we have a 119. We have a 118. So maybe I should have started with the 18s. 118. It doesn't really matter as long as you represent. Sorry. So I was saying it doesn't really matter as long as you represent all the data, because this is a frequency distribution. Yeah. So as long as you capture all the data, so you have the 119 now. So we have the 120s. So we have 122. We have 124. So this is the 124. That's the 122. We have a 125. You have a 127. So let's get rid of this. Then you have the 130s. I need another. I think I need a row here. Okay, let me just view the table. So we have a oh sorry, we had the 120s. Let me just view the table because I think I need to understand where my rows are going. Okay. So I don't need this. I don't really need the borders and the formatting. And then so you don't really need all the things I'm doing. I'm just doing them because I'm doing this for my in a Word document. But typically you're going to do this by hand. So let's do the 130s. Yeah. So you have the 131, you have the 132, then you have the 140s, you have the 144, then you have the 150s, so you have the 151. So if you look at this, let me get rid of the extra rows. So if you look at this now, this actually looks like a frequency. It looks like a bar graph, right? So this is how you do a stem and leaf diagram. So I actually get this from I get this from an exercise, from a self-test exercise in chapter 2. I don't know if it's numbered. So I told you these exercises actually have solutions at the end. So let's look at the solution. Let's go to the end of the book and see the solutions. So this was the chapter 2 self-help exercise. Can we find it? Chapter 3. Then we have so the one we are constructing should be for chapter 2. Do we have it there? Yeah. So I think it's this one, right? So if I zoom in, you can see that thing over there. So let me just grab it. So let me just grab it. So you can see what happened. What's going on? So if I edit, copy, so you can see that this thing, let me just change the wrapping. So you can see this is actually the same thing that I have just created over here. Yeah, so you see you have the 10 2 4 6 6, you have the 11 4 5 7 8 8 9, you have the 12 2 4 5 7, you have the 1 2, you have the 4. So this is how your stem and leaf display is actually going to look. Yeah, this is how your stem and leaf display is actually going to look. So we can actually do the let's do one more. Let's do for this data over here. So in this case we have data which is which has fractional elements in it. So this data has fractional elements in it. So one thing we could do is for instance, that's 11.3. So that's 0.1. Yeah, so that's the leaf unit. So when you have such data, let me first of all construct the stem and leaf display. So like I said, this is just for so that my data is aligned properly. But if you're doing this by hand, of course you don't need to so let me just put in the table to make sure my data is aligned. Let me just get rid of the borders because I don't really need them. So you have the 11. So your data actually begins from, I think it begins from 7. So you have the 7.5. Yeah. By the way, you have to insert this. Yeah. So you see that little line over there. I'll show you why in a bit. That's typically where you put your leaf unit. So by default, your leaf unit is let me see. By default, you normally don't have to put a leaf unit because your leaf unit is like a 1. Yeah. But let's look at this other example that we have over here. So in this case, we start with a 7, then we have an 8. The 7's done, so you only have a 7.5, right? Then you have an 8, 8 point nothing, this 8 over here, yeah. Then you have an 8.3. Then you have so the 8s are gone, right? Is that right? Let me just be sure that that's the data. Let me just be sure that's the data that that I actually get. Chapter 2. So I get this from the exercises, yeah. So we have a frequency distribution, we have So I'm just confirming the data. So it is an 8.7.5. Well, it doesn't really matter much, as long as we have the right computation. So anyway, so let's go to the 9s. You have the 9 point, you have a 9, then you have a 9.3, then you have a 9.6. So if you get rid of the 9.6 and the 9.3, then you have 10s. So you have a 10.0. So you have a 10.4, and then you have a 10. We just need a new column here. Then you have a 10.5. So that completes the 10s. Then you have the 11s, right? You only have one 11. So you have the 11.3. So there's just one little thing you have to specify here. You have to specify the leaf unit. So you need one of these, like I said. And this is where you specify. So we didn't have to specify it in the first example because the leaf unit was 1. What I mean is you get this 9, so that's 98 and that's 99. So you're not multiplying by any factor. But you have to, in this case now, because we have figures which are fractional, so you have to specify. I actually needed one of, I needed this one. So you have to specify a leaf unit. In this case it's 0.1, yeah. So whatever figure you see, actually multiplying it by 0.1. Let me just format this correctly. We don't have no, and you don't have a line, yes. Then, so this is how your stem and leaf display should look like. So when you specify the leaf unit, it basically means that if you have a 75, you multiply by 0.1. Multiplying by 0.1 basically means that you divide by 10. So that's the 7.5. So if you have the 8.0, you multiply by 0.1, yeah. Rather the 80, you multiply by 0.1. So you have an 8. Then 83 divided by 10 is 8.3, and so on and so forth. So that's how you actually recover the data. So let's do just one more example. We had some more data at the end here. It's not a big deal. I think you get the idea. So let's look at this other data with the big numbers in it. So in this case you have I think our values begin from, they begin with the 1000, 1161. So let's do this. So let me just get rid of these borders again. So remember, I'm only doing this to make sure my data is aligned. It has to be neatly aligned. So we have the 1161. So actually all you need in this last column is one number, yeah? Is one number. So this one thing you have to note. You don't put like a 61 in here, yeah? So this only is approximate, so you don't really need to, you don't need to be exact, as long as you get, because what you're interested in is actually the distribution, the frequency distribution. So the shape of your distribution is more important than the exact numbers. So you have the 1160s. So you have 1161. Do you have something else with 1160? Okay, I think it's only one value. So you have the 1120s. So you have the 06 over here, 1120. Now you have 1121. So we're ignoring the last value. I'll explain to you why. Because this doesn't have to be exact, right? We're more interested in the shape. So you have the 1130s. Sorry, we have the 1300s. We had 1100s, the 1200s. Now we're doing the 1300s. Yeah. So you have the 1300. So you have a 0. It's 1300 exactly. 1361. So we do the 6, we're ignoring the last bit. I'll explain to you why in a bit. So we have the 1400s. So we have the 1420. We have 1420. We have one of those. We have a 1426. So it's a 1420. We're ignoring the last bit. Oh, we had another 1300 here, yeah? 370. 1370, right? Then we have 1470. We have one of those here. We have a 1500. 1500s. We have a 550. We have a 550. You have only one of those. Then we have a 1600. 1600. We have a 1600. 1600s, 1620s. Then we have a 1680s. So like I said, this is approximate, so we don't need to put the last. Well, it depends on the leaf unit that you use, but the leaf unit I intend to use, because with the leaf unit I intend to use, then I don't really need these. So we have the 1700s, 720s, 1730. We have a 700 and we have a 700s, then 720. Then we have a 730. 730. So we have. So this is our stem and leaf display. So we're going to have this. So we have to, so we now have to indicate the leaf unit. So the most appropriate leaf unit here now is going to be 10. So this is the most appropriate leaf unit. So it's the most appropriate leaf unit. So what does this really mean? It means, for instance, here you have a 116 by 10 gives you a 160. Then you have a 120 by 10 gives you a 1200. You have a 122 by 10 gives you a 1220. You have a 130 here, gives you 1300. You have a 136 by 10 will give you 1360, and so on and so forth. So basically, this is how you do a frequency distribution by hand, yeah, using a stem and leaf display. So the other thing we have to look at is cross-tabulations. There's not a lot to say here. Usually cross-tabulations will give you, it's a kind of table that you use to see details about a distribution. For instance, if you have a categorical distribution and you want to see the quality rating. So this is how quality rating affects meal price. So typically on this side of your columns, you have the dependent variable, and then on this side you have the sorry, we have the independent variable on this side. Then you have the dependent variable, the variable that you're likely to be predicting. Another example is here. So in this case, you are looking at the verdict and the appeals success rate of appeals given a judge. Yeah. So you have the judge here, which is the independent variable, and the dependent variable on this side, the thing that you actually want to predict. I hope that's what I said before. So you have the independent variable and the thing that you are likely to be predicting. For instance, given meal price, we want to be predicting if the meal is going to be good. Then on this hand, given a judge, you want to know if the likelihood that a verdict will be upheld. So sometimes this suffer from what you call the Simpson's paradox. Simpson's paradox, which if you look at cross-tabulation like this one, for instance here we have Judge Luckett and Judge Kendall. If you look at this data, you can see that the appeal success rate for Judge Luckett is actually 14%. That means that his judgments are more frequently reversed at the higher court than Judge Kendall. So based on this, you could say that Judge Luckett, Judge Kendall's judgments are more robust. Based on this, you can say that Judge Kendall's judgments are more robust and therefore is a better judge. But if you actually look at the cross-tabulations for the individual judge by type of court, you notice that Judge Luckett, for instance, who appears to be, because in this cross-tabulation, which is summarized, which is where the data is obtained from these two cross-tabulations, you find that actually Judge Kendall has got a lower reversal rate. Yeah, he has a lower reversal rate. So based on this, you could say Kendall is the better judge. But if you drill even further and you analyze this data by a type of court, you actually find that in both types of court, because in this case you could see that actually Judge Kendall has got a higher reversal rate. Judge Kendall has got a higher reversal rate in the common pleas court, because you can see Judge Luckett only has a reversal rate of 9% and Kendall has 10%. And in the municipal court, still Judge Luckett has got a lower reversal rate. It's actually Kendall has a higher reversal rate in the municipal court. So what is really happening? So what is happening here is simple. It's just that the reversal rate for the municipal court is higher, and Judge Luckett has a higher proportion of cases in the municipal court, because Judge Kendall has only 20 cases in the municipal court and Judge Luckett has 100 cases in the municipal court. But his rate of reversal is actually a lot lower than, because if you look at Judge Kendall, for instance, his rate of reversal in the municipal court is actually around 20-25%, and Judge Luckett's rather is 20%, and Judge Luckett's reversal rate in the municipal court is actually only 15%, because there are 18 out of 118 cases, right? So Judge Luckett is actually the much better judge. So when you observe this kind of effect, it's called the Simpson's. It's called a Simpson's paradox. Maybe let me just show you how to create a cross-tabulation in Excel. So you can have this kind of data. For instance, we have a restaurant data, and this is the restaurant number identifier, and then this is the quality rating, and then this is the meal price. So what you're really interested in this case, what you're really interested in this case is the meal price. For instance, if you want to cross-tabulate meal price against quality rating, I think that's the situation we had in this table. For instance, this kind of table, if you want to to figure out how the meal price affects the quality rating, so you just go over here. Maybe let me start all over. Let me just start by clearing content. So you have first of all, you want to create your data. You want to have your restaurants. You want to have your meal price. then you have your quality rating. In this case, you're going to have random data. No, you don't really need random data here. So this is going to be, because these are indices. So let's just say these are going to increment to, let's have data for maybe 8 restaurants. Let me just fill for 7 restaurants. Meal price could be random between some value, let's say 10,000 and 50,000. Oh, there's a negative here. Okay, so let's generate this data. Then the quality rating, let it be some random value. So I'm only doing this for speed. Typically you'll have actual data in here, so some random value between 1 and 3 inclusive. So you have this kind of, so if you want to do a cross tabulation, it's good to format your data as a table. Let me choose that format. So then select your data, then go to insert, then you want to insert a pivot table. So it's going to ask you to select some data. So in our case, the row labels are going to be, I want our restaurants to be the row labels here. Then the columns are going to be, because we said on the columns actually want the independent variable. So the independent variable is very likely going to be the quality rating. Then the this should probably be, so in the columns we want the independent variable, and that is going to be meal price. So it's the thing that you're actually going to use to to predict. I think in this case it can actually go either way. For instance, you'd have the judge here, right? But in this case I think it can actually go either way. So maybe let's have quality rating. So the higher the quality, as we assume, the higher the meal price, then you're going to have the meal prices here. So this, you can see what's happening here. So you have the one, you don't have any twos, do we? So you have the quality rating, and then you have the meal price, and then you have the restaurants on this other side. If you actually go rid of this, what would happen? So you only have so you can get rid of that level of detail, and then but if you add even more detail, you can actually add the restaurants there. So this is actually a cross tabulation. It's very similar to what we saw here. It is a cross tabulation which is similar to what we saw here. Yeah. So I really don't have much to say about cross tabulations, but there is one more thing, and that is scatter plots. Yeah, so a scatter plot will basically show you the relationship between two variables. For instance, in this case, if you wanted to get a scatter plot for this, it's very easy with Excel. So a scatter plot is basically going to show us the relationship between two variables. So in this case, we don't really have we have a kind of negative correlation. If you fit a line here, you can see that what you have here is a simple, is a sort of negative correlation. Yeah. So the shape of the scatter plot will show you the strength of the relationship between two different variables. So if you have a line of this sort, you have a strong positive relationship. You have if the line of fit is actually almost along the diagonal and going upwards. If the line of fit is this kind of line of fit, then you have a negative correlation, a strong negative correlation. If you have something flat, then it is what you call no correlation. So typically, your data is going to be scattered around, and then you have to to show a line of fit. So this brings us to the end. So this brings us to the end of this chapter.